Hello, my name is Tomi Ma. I'm from Nokia, and I will be telling you about the OpenEdge server. So, the OpenEdge server is Nokia's solution for the server in the edge, and it became an OpenEdge server when we contributed the design to the OCP community. So, one of the key things for Edge server is that it can be actually also installed all around the edge of the network, when it's close to the radios and close to the end user, so that the delays can be managed and the user experience can be guaranteed. And typically, the edge sites can be cell towers, for example, or equipment closets, where the environmental conditions may not always be the kind that we are used to in modern data centers. So, for example, there may be space constraints. So, for that reason, the solution needs to be compact. And there may be varying kinds of power feed available at these sites. So AC and DC are supported, and the different flavors of one-phase, three-phase solutions can be then supported by using different power delivery units. Also, the power feed capacity can be limited. So the solution needs to be modular, it needs to be scalable, so that we can start with maybe a couple of servers, or we can, if needed, we can scale up to a full rack, or even several racks when that makes sense. Then the thermal environmental can be somewhat more harsh than in a typical data center. So the temperature spec has been increased up to plus 45 degrees. And we are also supporting the NEP's plus 55 short-term temperature. And also seismic tolerance is provided. So this is a picture of the 1U sled. It's an Intel Xeon SP Cascade Lake based. And we are supporting up to, this time, up to 24 cores at 22.5 gigahertz. And the TDP for the CPU is 205 watts. And both the chipset types, PCH, C621, the basic solution, and then the C628 for the quick assisted functions when those are needed. The sled is half width and 215 millimeters in width and 427 millimeters in depth. And like typical Pearly designs, this has 6 memory slots, or 6 memory channels, and actually 8 memory slots. We are supporting also 2 additional slots for non-volatile DIMMs when those are needed. And management is done via Redfish or IPMI 2.0 on the BMC. The BMCs are accessed through an RMC unit, which is one of the modules of this OpenEdge chassis, and providing network connectivity to all the sleds in the chassis. And there can be up to 5 1U chassis, 1U sleds in the chassis, but also 2U sleds are supported. The 1U server has 2 hot plug 2.5-inch SSD slots, Both SATA and NVMe are supported. And there are also 2 internal M.2 modules, either 80 millimeters long or 110 millimeters long. And then for the expansion slots, there's always the OCP mezzanine slot. This is a version 2.0, so the one is that it's not hot pluggable, but that can be added in the future. Then there's one slot for a full height, half length PCI Express card. And in this 1U sled, the capacity or the power budget for that card is 75 watts. So accelerators can be used there. The 2U sled has the same motherboard as the 1U sled, so all the main functions are the same. The 2U sled provides some more storage options. So there are two more 2.5-inch hot plug SSD bays supporting SATA and NVMe drives, but this time up to 15 millimeters high, so a bit more high-performing SSDs or NVMe's can be used there. And then there are also options for more I/O because we have the more height, and so the number of PCIe cards can be more. And we also support a dual wide, full height, full length PCIe slot that can be used for different kinds of accelerators. GPUs can be put there, or it can be an FPGA accelerator or whatever standard form factor is supported here. The maximum TDP for the CPU in this 2U model is 250 watts. And the power budget for the accelerator is 300 watts. Okay, so these are the building blocks for this openness chassis. And what we have contributed this 3U chassis to the OCP Foundation today. So all the design files are available there for anyone to use and to further develop this system. So we have CAD files, and then the design files also for the internal printed circuit boards. There's a power distribution board and a backplane and the design files for those are also included there. There are 2 PSUs in the system, typically used in 1+1 configuration, so load sharing, and one power supply can feed the entire system if one fails. And then there's the RMC unit that is managing the power supply units and providing the network connectivity to the sleds via the backplane. And this slide is just saying that we are supporting the standard form factor of storage. 2.5-inch SSDs are supported, and also those internal M.2 modules. And I don't have any PCI cards, NIC cards, anything listed here, but any standard NIC card or GPU card can be installed there. Okay, I have some more details about the hardware. There's a bit maybe repetition here, but I can try to focus on the parts I didn't mention yet. So, well, here you see actually the block diagram of the chassis. So there are 2 PSUs connecting to a power distribution board, and also the RMC unit is connecting to the power distribution board, and the backplane, which is vertical in the rear of the unit, is then connecting to the power distribution board, and then sleds connect to the backplane. And the two cards shown here in gray, are also part of the contribution that we have made. PSUs are the power feed capacity is 2,000 watts each, so one PSU can feed the entire system. The power budget for the 1U sleds is 400 watts each, and for 2U sled it's 700 watts. Power supplies are platinum of efficiency, AC and DC both supported. And cooling is part of the sleds, so there are no cooling fans in the chassis itself, but they are in the rear of the sled. And the cooling air direction is configurable. It can be from front to rear or from rear to front, depending on the site solution. So sometimes the airflow can be reversed at the site, and so we can, with this feature, we can adapt to that. And the chassis manager, or RMC, rack manager, management controller, is basically managing the power supplies, reading sensors. We can read all the voltage information, current, power, and we can monitor the state of the power supplies via the RMC. And like also shown in the block diagram, the RMC has a block, it's a switch, unmanaged switch that is providing Ethernet connectivity to the BMCs of all the sleds. So it's just a convenient way to connect management Ethernet at the site. Power distribution is done also via the backplane. Okay, front view, just showing the components of the chassis. And this picture is showing how or which kinds of configurations are possible in the chassis. So it can be 5 times 1U chassis. It can be 3 times 1U plus 1 2U, or 1 1U and 2 2Us. And there are detachable shelves in the chassis that can be taken out in order to make room for a 2U sled. And the installation is toolless. And by the way, all the cabling, all the maintenance is from the front side in this system. So no interfaces in the rear side. So for easy management. Okay, here you can see the block diagram of the 1U sled. Maybe worth mentioning is that in this design we have one common riser card that is supporting the SSDs and the PCIe I/O options. And using that riser, we can redefine the PCIe connectivity inside the server when needed. And same thing for the 2U server. The blue box here is the riser card, and all the PCIes and SATA interfaces are routed via that riser. So the connectivity can be redefined by redesigning the riser card. This is sometimes needed when there's a limited amount of PCIe lanes, which is the case with the current Intel Xeon CPUs, especially with a one-socket server. This is the RMC, and like already mentioned, management of the PSUs mainly. The controller is of the AST 2000 family. It's 2020. So one of the most used BMC chips that there are today. There's a USB debug port in the front panel, providing a serial port to the controller. And then there's this unmanaged switch to provide the connectivity to the sleds. So one RJ45 1000 base T and two 10 gig SFP plus cages are supported. And some key environmental specs listed here. So, like I said, the normal operating temperature range is from -5 to +45. And we are also supporting the NEP's short-term operating temperature range from -5 to +55. And of course, all EMC, all regulatory requirements are met. And we are also supporting the seismic tolerance to the risk zone 4, so earthquake tolerance. And acoustic noise specs are met. We are doing a full NEP's compliance test for this system, which is actually quite important for some or many telco customers. And finally, just to summarize our contribution, so we have made the contribution of this OpenEdge server chassis. We have provided the specification, all the design files, and applied for the OCP accepted recognition. And we have got that recognition in the March of this year. And the OpenEdge wiki pages are under the telco project. So this is a sub-project. And finally, we welcome all companies, anyone to join the OpenEdge ecosystem development. And please join the regular OpenEdge project calls that are happening on a monthly basis. And we also, Nokia is also present in the next OCP regional summit in Amsterdam, so please welcome to visit us there. Thank you.
Thank you, Tomi. 有请 Gary。